Here's a quick example of our Z-buffer shaders, or just in general, our effects system running. In this particular case, it's a depth of field shader. We've got this slider hooked up here to an action, so that if I position this down near the bottom here, you can see this wall and the distance is in focus. And then as I pull the focus forward, you can see this amplifier here is starting to come into focus. And if I keep pulling the focus forward, about there, you can see this amplifier is in focus. And then if I pull it right forward to close focus, you can see this amplifier comes into focus. So that's literally calculating the distance of the pixels from the eye. So as I rotate, I'm actually going to change that distance. So you can see this amp here is blurry here, but if I rotate it to that correct distance, it now sharpens up. And then, as I say, you can adjust that focal plane using this slider. But the cool thing is there's just an effect applied to a render kit, and we can actually look at the code involved. So one of the neat things about this is you can see that there's a standard lighting shader applied to the forward pass, so that's doing the effects on the floor and the general lighting in the scene. And then there's a post processor applied to the entire scene, which is our depth of field shader. And that's literally just the named HLSL, GLSL, or Vulkan code dropped into that effects folder. You set up the JSON file to say this is a DOF shader, that it needs the Z buffer, and magically you can expose it. And then developers could also, or users could also put that on their 3D models, even simply. You just drop it down from the list of shaders. This gives you a sense of the kind of power that's exposed through the shader system now. Cheers.